The next talk will be by Dr. Anderton from the UK, the subject of Einstein's relativity from perspective of Boscovich theory.
Thank you for letting me do this talk. Einstein's paper on special relativity is what I'll be looking at, and it gives no citations, references, so it can give the impression that it's all coming from Einstein's imagination based on thought experiments. But I'm proposing that there's a tradition of physics which leads up to what Einstein is thinking about. And so this is Max Born. He's one of the friends of Einstein, and he says it gives you, which is 1905 paper on special relativity, gives you the impression of quite a new venture, but that is, of course, as I've tried to explain, not true. So he admits Einstein was working from an earlier tradition of relativity, and so we just need to work out what it was. So people like Galileo talked relativity, and between Galileo and Einstein there was quite a lot of work on relativity, which now gets overshadowed by Einstein. So I've gone back to the original German of Einstein's paper, and I found, I think, a better translation. This is the usual translation, and I'm going to denote that as OEM, and I found what I consider to be a better translation by this person. Now, as per the June 2019 issue of Physics World, when Einstein was in Oxford, England, he was lecturing in German and not English. He wasn't fluent in English, and because he was speaking German, his audience had difficulty understanding him. And I think Einstein should have clarified that the translations into English were correct from what he was talking about in German. Well, I don't think he really got involved in too much in that, and he relied on his translators because he was more involved in lots of politics. And so, taking an example, the OEM translation says this, and then we shall consider a better translation translates it as that. And the difference is this translation mentions point particle.
Pointer.
Yeah, so this translation mentions point particle, and this translation doesn't. So if we go back to the original German, that's the German, and and that word and that word, and it probably translates best as point particle, but the usual version omits saying that. So if you read the rest of the paper, it does mention things like material point, and I translate that as still talking about point particles. So what I understand is Einstein's paper on special relativity is dealing with point particles. Now, the theory of point particle goes back to Newton, and it was further developed by Boscovich. So the basis of his paper is the Boscovich-Newton point particle theory. So we have a connection of special relativity to earlier tradition. And if you read in the OEM translation, you're not really picking that up so easily. So a relevant book on Boscovich theory is by my friend Dragoslav Stogovich. I've got a copy of the book here. He's a chemist in Serbia, And according to him, everything is built up from elementary particles, the point particles of Boscovich, and it builds up to the other particles, and the force between particles obeys this sort of thing, this curve. And so that's the book there. Oops, all the way done. Something. So, okay, so here's the book, and you can build up things like for the electron in orbit around the nucleus, you have allowed and forbidden orbits, and you get all these other curves as well, which ties into quantum physics. And I also have a paper by Augustus Prince, who's worked out the mathematics of Boscovich's theory, because when Boscovich wrote his theory, the mathematics wasn't available on the day to deal with it. So going back to the translations, in the original translation which we're used to, it's saying this, and the newer translation is saying something very similar. And what we should really be doing is reading that in the context of point particles. So in the context of point particles, when you first see uniform, what we should note as that can also apply to acceleration. So you have uniform equations of motion of Newton. And which are these equations? These are basic Newton equations for point particles. What might have obscured people from realising that Newton's equations of motion are still valid is the usual translation says to first approximation for that. And in the better translation, there is no footnote. So I need water. So the usual translation is adding a footnote, which is not there in the original German. So it's giving a completely false impression of what's being talked about. So the first translation is saying that Newtonian physics is an approximation of special relativity. So NP, Newtonian physics, approximately special relativity. While the second translation is saying Newtonian physics is special relativity. It's quite a big difference. And the correct translation is Newtonian physics is not an approximation of special relativity. But however, most people think Newtonian physics and special relativity are not the same because they look different on things like time dilation, but we'll get to. For the moment I'm pointing out special relativity is really Boscovich and Newtonian physics. So getting to the issue of the maths, the usual translation is this, and the better translation is this. And they're quite similar. No, they're different translations, sorry. And the difference, one of the differences, he's talking about velocity of light, and this one's taking the speed of light. And the trouble is, the German word can translate either to velocity or speed. And I think really the word should be speed. So he's really talking about speed of light, but also the better translation is talking about two-way light speed, while the usual translation seems to be interpreted as one-way light speed. So if you're thinking of the two-way light speed as being constant, then that's bringing it more in line with Newtonian physics. So I think it's a mistake to think it's one-way light speed constant. For two-way light speed, if you've got light going in one direction as c minus v, and then hitting something, rebounding, coming back at c plus v. For v greater than 0 and taking it to obey the usual Newtonian physics, then c minus v is less than c and c plus v is greater than c. So the one-way light speed is variable. So when you add these two together and take the average like this, that one-way light speed plus that one-way light speed, then divide it by 2, you get c. So c is a constant, and that's the two-way light speed. Thus we still have Newtonian physics. One-way light speed is not constant, it's just the two-way light speed that's being constant. And when you look at the maths, the better translation seems to be justified in taking it to mean two-way light speed. Just that Einstein didn't use that sort of terminology. So now we get to the time dilation equation. When the belief was that Newtonian physics is approximately special relativity, the way that is looked at as when v is very small, then that equation approximates to being Newtonian physics. And that's false. The correct interpretation is that is a Newtonian physics equation. It's not an approximation to Newtonian physics. That is a Newtonian physics equation. So, if you look at Newton, when he writes about things, he does talk about absolute space and absolute time, and he also talks about relative spaces and relative times. So, from the point of view of Newton, time dilation is okay, you're talking about relative time. And when you go back to Newton, I found there are also, this is a mistranslation of Einstein spotted in physics, Journal of Physics in 1963, as an example. And when you go back to Newton, it's been spotted that Newton is also mistranslated. There's mistranslations in Newton. So I think there have been mistranslation problems that obscured concepts in physics, and really there should be a discussion of Boscovich's theory, a theory of point particles with action at distance by fields and particles not coming into contact. And Boscovich used to be taught before Einstein in the quantum revolutions. So the conclusions are, looking at Einstein's 1905 paper from a context of an existing tradition working on similar themes, and we can get a relativity that's quite a bit different to the one that we are usually presented with. Einstein's innovation was dealing with light as particles in his 1905 paper on the photoelectric effect. And this is really the reintroduction of Newton's idea of light as a particle. And this led to a wave-particle duality concept of quantum mechanics later. So Einstein's 1905 paper on the photoelectric effect dealt with light as particles, and it was not being properly appreciated that his special relativity paper is also dealing with light as particles. So the two papers were really unified. Finished. Thank you.
So we go now to a discussion. Any question to Roger?
Can we first ask second election?
Second.
I have
Yeah.
question
Okay.
and comment for last.
So you start.
Yes, where is it speaking? Thank you. Concerning the radial equation of the partial wave which you have presented, you told us that it is in fourth order, but I didn't see that it is fourth order. It is here. It's a radial equation of the partial
You
wave.
can have a seat and then
Yeah.
I would like to ask you.
Okay.
Maybe I listen now.